Okay, so we're gonna have now an example of interactions between two qualitative variables. So what happens when you have two dummy variables and you want to do interaction effects among them? So for this, we're gonna use a cars data example. In this data set, you can find it on under datasets. It's cars.csv, so you have to download it. You can actually read it, and let's say with cars using the read CSV function, and the C for cars is in capital letters. Let me put the code in there. So for this example, reading data. And again, this is we are going to just be naming these interactions between qualitative variables. Okay, so let me just put the data set in there. Just as a quick, let me just print a structure of the data set. We have here the price of the car, mileage, make, model, trim, type, cylinders, liters, number of doors, if the car has cruise control, if the car has sound, and if the car has leather. Those three are dummy variables. Those are already dummy coded, but they are read as integers. Remember, that's the first thing we have to do. So what we want to do first is change them to be factors. So let's go ahead and do that really quick. So we want to say cars, $. If you want to change something to be a factor, let's say cruise, you would just say as factor of that variable, and you just override it. So that variable, now if you look at the cars object, then it has a factor as cruise. We are going to do the same thing for sound, whether the car has sound or not. And these should be enough there. So you can see sound now is a factor with 2 levels, and then finally leather. So that's the approach on, first of all, on that you need to take when you're going to do any model. Like I said, sometimes you could get by not having those dummy those dummy coded variables changed to factors, but we would like to do that just for consistency purposes. All right. So now that we have the variables coded correctly, let's take a look at interaction effects among predictors that are qualitative. And for specifically, let's take a look at the cruise and leather interaction. But first, let me just show you what you can and cannot do with interaction. Let's take a look at the type of car. So the levels of these variable, let's say cars, $, type, is convertible, coupes, hatchback, sedans, and wagons. So the convertible is the let's say the base level for this particular example. So let's go ahead and create a model. Let's call it regression 1. And again, my naming convention is pretty bad, so I just name everything the same thing, which is not good, but it's just to avoid having to name it something else. So let's say I want a model using mileage as a predictor, and then I want to use the type as a predictor. Just those two. Okay, and then let's say cars. Let me show the summary here. So let's change the options here so that we get rid of the exponential notation. Right, so now we have here the variables. Mileage, as mileage increases by 1 mile, as the variable mileage increases by 1 mile, then on average the car price decreases by about 19 cents, holding the other variables constant. But then we have here type coupe, and that means that on average a coupe car is about $23,000 less than the class that you left out. Remember the levels for that class. for that variable is you're comparing against convertible. So that's why these parameter estimates are negative. So it might not make sense to compare always against the convertible car. It might make more sense to compare to a sedan, so you might have to relevel it. But what I want to come to is to the fact that there are 4 dummy variables created from this variable. Is it okay for me to do an interaction effect between these variables? And the answer to that is no, you can't have an interaction between dummy variables created from the same variable. And the reason for that is, well, first of all, you're not going to be able to do that in R. Is because, well, these variables are 0 and 1. If the car is coupe, it's not going to be a hatchback. So multiplying type coupe times an interaction, which is making an interaction is a multiplication. So if you multiply this dummy variable times this dummy variable, it's always going to be 0, because if one of them is 0, if one of them is 1, the other one will be 0. So there's no, you're always going to get those interactions to be 0. So those are meaningless. The same, so that's something to take into account. Interactions, you don't do interactions between variables, dummy variables coming from the same type, the same variable. But if you had another variable, other dummies created from from another variable, categorical variable, then you can do that. Right. So having said that, let's create now another regression. But now let's choose whether the car has cruise control and whether the car has leather. Okay. So let's just rewrite this really quick. So we have here having cruise control added about $10,000 to the car, compared to those that don't have cruise control, and adding leather about $4,000. And this might not make sense in today's world. Almost every car has cruise control, and but this is just an example. It's an old data set as well. So now let's take a look at an interaction between those two. So let me add that interaction between cruise control and leather. Let's take a look at the let's take a look at the summary for that regression. It's regression 2. All right. So first of all, things that you will note is that now all of a sudden one of the original variables becomes insignificant. So if we take a look at it here, both were significant, but now leather becomes insignificant. And we said that that's likely going to happen because these multiplication of cruise and leather is actually going to be very close, very similar to either cruise and leather. I mean, if you take a look at the model matrix from this of regression 2, you will see that this is the new variable created. Cruise, when you're multiplying 1 times 1, you get 1 back. So this variable here is also sort of a dummy variable on its own. It's going to be 1 when the car has both cruise control and leather. And it's going to be a 0 when the car either doesn't have cruise control or doesn't have leather. So this variable is pretty similar. It's going to have a very high correlation between, it's going to have a very high correlation to cruise, to the dummy for cruise and to the dummy for leather. So that's the reason why you will see that these summary will indicate that leather is not significant anymore. So the way that we just do it for interactions always is to take a look at the interaction. Is it significant? If it is, then we kind of disregard the p-values for the original variable. All right. So having said that, let's go ahead and make some interpretations in here. So let's first, let me just first copy and paste this model here so that you see what we are interpreting. And then let's take a look at the interpretations. Okay, mileage is not in a interaction, so we can interpret it the same way. So I'm not going to write it there. As mileage increases by 1 unit, then on average the price of a car decreases by about 19 cents. But when you talk about what effect does having cruise control have on the price of a car? Well, in that case, well, it's going to be about $7,000 more. But if that car has both cruise control and leather, then we just add another extra $4,000. So now we can see what these interaction between the two qualitative variables sort of tells you. It's basically telling you that, well, this is the effect of having cruise control compared to having no cruise control. It's adding about 7,000. But I have to know whether the car has leather or not. If it doesn't have leather, it's just 7,000. But if it does, I would add 4,000 extra. Okay, so let's write it down so that it's so we are going to call it effect of having cruise control. So we are going to say that on average. So we interpret it the same way. We just go over the options that you have because these are dummies. On average, if the car has cruise control, the price increases by about, let's say 7,000. Let's say that. By about that, well, but let's say if the car has no leather, but if the car has leather, then we would just add that 4,000 in there. So in total, it would be all that 4,000 plus that 7,000. Just put it in there. It's going to have rounding errors, but you know what I'm trying to say. Okay, so let's just put it here. So on average, if the car has cruise control, the price increases by about 11,000 if the car has leather. So that's probably the easiest way to interpret interactions when you're interacting to qualitative variables. You can go over the options that you have. So you can see that this is the difference of having leather. Having cruise control is about $7,000, but that will depend on whether the car has leather or not. So again, the same way interactions are interpreted. If you want to go ahead and try to remember what it means, it just means that I can't know the effect of having cruise control unless I know if the car has leather or not. If it doesn't, then this leather one option is going to be 0, so all of this goes away. But when it has cruise control, then that 7,000, we should add that, must add that 4,000 extra dollars that is included by having both cruise and leather. Okay, so hopefully that makes sense. In terms of interaction plots, there is one type of interaction that you can get and using that SJ library that I showed you before. So you can use the SJ plot library. And you can use the same code that you used if the interactions were not qualitative. So you can use actually the plot model, and you just have to plot the model name. We call it regression2, and the type is equal to int. Just remember, it's going to give you the marginals, marginal interactions, and that is basically plotting what you have. So let me just show you what it means. So you have car having cruise and not having cruise control, and having cruise control is interacting with the leather. The way that you would look at it is if you want to go ahead and imagine that there is some sort of a line. So let me plot it like this so that you can see it better. So you can see a line between this and this. So between red and red, and then so let's do this. Let's change the color here. Let's change it to red. And you can have another line, and that line should be between this and this. And sort of imagine that these are the slopes. And because the slopes are different, then that means that there is an interaction present. So in other words, the change in the price is steeper going from no cruise to cruise if the car has leather. So that's what you see up here, as opposed to when the car doesn't have leather. So that's the extra $4,000 that you see there. Again, hopefully that makes sense. We will see more on that with more examples as we go on.